I'm Adam Middelkoop with Nautel Customer Service. Today we're going to take a look at getting RDS configured in a preset. We'll start by getting logged into the AUI, then going through the menu to the presets page and clicking to edit the desired preset. In my case, I'll be making these changes to the one I've called Normal Preset. The internal RDS encoder is used to put out static values or to take values provided by an external automation system and broadcast them. To enable the internal encoder, we'll have to go to the RDS tab here in the editor. From here, toggling RDS to enabled expands this screen and provides quite a few more fields to populate. The first of these is the PI code or Program Identification Code field. This is a value used to identify a station and is generated in accordance with your local regulatory body's rules. It's entered here as a hex value, excluding the leading 0x prefix. Next, we have our data source selection. The options here will vary by transmitter type to reflect its capabilities. My VX is capable of using internal values, ASCII formatted values over IP, or UECP formatted values over IP. When sending either ASCII or UECP formatted data to the transmitter over an IP connection, it must reach the transmitter's IP address on port 7005. This port is fixed and cannot be changed. Depending on your network configuration, you may need to work with your local IT support to establish port forwarding or firewall rules to allow that connection. Transmitters capable of receiving ASCII or UECP formatted data through a serial connection can have that source selected here. For now, I'll just stick with the internal values. The injection level field is used to set how much modulation percentage or kilohertz deviation is used for the RDS subcarrier. This is displayed and set as a percentage, with 5% or 3.75 kHz being the default and 10% or 7.5 kHz being the maximum value. The phase field is used to define a phase offset in degrees for the RDS subcarrier. This can be useful to maximize performance if you're employing an external stereo pilot and can be set between 0 and 360 degrees. The PS name, or Program Service Name field, is an 8-character string that is most often used to display the station's call sign. The next three fields are used for the scrolling PS, dynamic PS, or DPS function. The first field lets us choose the scrolling speed as fast, slow, or off, which disables the function. Slow will trigger a transition every 10 seconds, and fast will trigger a transition every 3. The scrolling PS name field is a 64-character string that is sent 8 characters at a time to populate the PS field on a receiver. The scrolling speed is used to determine the rate at which the next 8 characters are sent, while the scrolling type is used to determine if the transition is done to move 1 character at a time through the string or 1 word at a time. If word is selected and the word is longer than 8 characters, it will be scrolled by character until it has all been displayed. The radio text field is another 64-character string. This field is most commonly used to display artist and title information, but may also be used to display promotional or station information as well. All 64 characters are sent at once, but individual receivers handle that data in accordance with their design. The PTY, or Program Type field, consists of a list of predefined program types. Some receivers can use this field to scan or store stations by program type, or they may alter their display with an image that represents the programming. Since the options here are fixed, the one that best represents your station's format should be selected. In my case, I'll go with option 5 for Educate. The PTYN field, or Program Type Name field, is an 8-character string that can be used to supplement the PTY selection. I'll add HTML5 here. The music speech flag is used to denote your station's main format. Some receivers may alter their volume or EQ settings based on this flag. Traffic info flags are used to denote if a station is broadcasting traffic programming or a traffic alert. Some receivers may have the ability to automatically switch to a station using the traffic alert flag. Alternate frequencies are used in cases where programming is available across several separate frequencies. A receiver may have the ability to tune to whichever listed frequency has the highest receive strength. The artificial head flag is used to denote if the programming was recorded using a binaural recording device known as a dummy head or an artificial head. If the station's programming has been compressed, the compression flag can be set to indicate that to receivers. For stations that change format, the dynamic PTY flag can be set. Some receivers may alter how they handle the station's PTY data based on this flag. The last field I have here to edit is the DI stereo or stereo mono flag. This is used to denote that the station is broadcasting in stereo. That's all the fields I have available, and I've got them set how I want them for now. I'll save what's been done, and if I need to change anything, I can always come back later. And that's all my changes saved, so when I go on air, these RDS values will be what are used. It's important to note that even though I've populated a given field, and my transmitter will be broadcasting it, some receivers may not have the ability to decode or display it. Further, some receivers may display certain fields differently than others. When testing RDS settings, you should keep in mind that not all fields will be displayed by all receivers, and not all fields will be displayed in the same place or in the same way. It's important to use either a dedicated decoder or a variety of receivers to evaluate an RDS configuration. I've done all I can for now, so I'll close out of this session. I'd like to thank you for staying with me, and I hope that you'll join me again in the next video.